All right, well, here we are. It's Friday. We're just going to learn a few formulas. I hope you all have a good Thanksgiving, and I will see you when I get back. Just for your warm up, I wanted to do this problem. Hopefully that you guys know how to do this. Take a second and pause the video and see if y'all can do it. Agree on an answer, and then we'll come back and we'll check the answer. So please pause the video right here. Okay, well, welcome back. And so basically, when you look at this is an old AP question, obviously. And it's really just testing the fundamental theorem of calculus. The fundamental theorem of calculus tells us that the derivative of the integral is really just the function. The upper limit is x, so I don't have to use the chain rule. I just simply replace u with x, and I'm going to get cosine of 2 pi x. So the correct answer is, is D. And obviously that seems very, very simple, and it is, but they're going to test it at some point. And here is an example of one way that they tested just in a multiple choice question. So as long as you know that the derivative of an integral is the function, it's a pretty easy problem. All right, so there we go. That's it. All right, so today we're just going to learn a few integrals that we didn't know. I'm gonna derive a few of them for you. And really, it's just a matter of memorizing these. You're not going to see them very often on the AP test. I can get tangent and cotangent fairly simply by deriving them, so it's up to you whether you want to derive them every time or you just want to memorize them. But you need to know these formulas. So they're listed here. They're in your notes. So we're going to just derive a few of them just so you can see where they come from. Because they're really, tangent is really not very difficult to derive. The tangent itself is sine over cosine. And if you treat it that way, what you have is a u du thing. We have a substitution. Because I have a fraction, I'm going to let u be the thing on the bottom. So I'm going to let u be the cosine of x. Du, the root of cosine, is, what's the root of cosine? Negative sine. All right? Yeah, okay. So I obviously need a negative, so I'm going to put a negative here and a negative there. And what I have is negative the integral of du, which is negative sine x dx, over u. So hopefully that's just layering out as u as the ln of the absolute value of x when you integrate it. So it's negative ln, the absolute value of x, sorry, not x, u. All right, yeah. Plus c, you know the plus c. Okay. But u is not u. U is, what's u? Cosine. So it's negative the ln of the cosine of x. All right, and you'll see it written this way, but you'll also see it written another way. It's the ln of the absolute value, okay, is there, but the negative is still a power, so it's the absolute value of the cosine of x raised to the negative 1 using a log rule. So what you really have here, the cosine to the negative 1 is secant, it's the reciprocal cosine. So it's the ln of the absolute value of secant of x. This could be written either way. More often than not, it's written with the secant, but it doesn't have to be, all right? So you need to know that those two expressions are the same thing. All right, okay with that? Hopefully you are, because you're not here to answer me. But that's all there is to this. Go ahead and pause the video if you need to get caught up with your writing. I'm going to go on and do the next example here. All right, cotangent works the same way. I do not memorize it so much. Well, I do, but then I don't have to because I know how to do it. Cotangent is cosine over sine. And I'm going to do the same type of procedure. I'm going to let u be the thing on the bottom. So the derivative of sine is cosine. So I just simply have the integral of du over u. Very easy. It's the ln of the absolute value of u. No negatives this time. What was u? Sine. So it's the ln of the absolute value of sine x. Let's see. You can memorize this or you can derive it. I don't care. You may pop up. It has one, make maybe one question on the AP test, but it's just an interval of what you don't know. Okay? All right, you can pause the video. I'm going to go on to the next example. Again, no big deal. All right, secant. Integrating secant requires a trick. There's no mindset as to why you would do it. And so I'm going to put a Pythagorean identity here, though. 1 plus, what is it, tangent squared equals secant squared. This is what I'm going to play off of. All right, my Pythagorean identity is, cosine squared plus sine squared. But anyways, that's one of the ones we learned last year. So to integrate secant, it requires a trick. This is why I just memorized this, because there's no way I'm going to remember this trick. But I thought I'd show it to you anyways. All right, so I'm going to multiply by secant x plus tangent x on the top and on the bottom. Oh, why did I do that? So what I'm going to do is I'm going to multiply the top through, so I get secant squared x plus secant x tangent x. So I'm just distributing the stuff through over secant x plus tangent x on the bottom. Do you see where I'm heading? Do you see a u du? Because I do at this point. All right, I'm going to let u be the bottom. So u is secant x plus tangent x. And so du, the derivative of secant, is secant tangent, which I see up top. The derivative of tangent is secant squared. Looky there, there's your du. All right, so now what we have is really just the integral of du over u. Okay, which is the ln of u, or the ln of the absolute value of u, but guess what? That u is the ln of the absolute value of secant x plus tangent x. All right, plus c, of course. I would remember to multiply by secant plus tangent. I mean, there it is in my answer, so I just memorized this. So I just know that all these trigs, the secants, the cosecants, the tangents, and cotangents all have ln of something, and I just remember this something. But it's up to you. Whether or not you'll see this on an AP test, it's unlikely. It'll usually be tangent or cotangent. They'll integrate, but just to be complete, and I want you to see this. I want you to memorize it, but it's not in the scope of things a huge issue. Cosecant follows the same trick. I would multiply by cosecant plus cotangent to save some time, but pretty much cosecant plus cotangent, I would multiply by that on the top and the bottom. So what I'm going to do is let you guys do that on your own. You can pause the video here and see if you can work it out. You'll come out with the formula. It's the ln. Ooh, is it negative? Let's see. You'll come out with the formula. The integral of cosecant is negative. Yeah, negative ln cosecant plus cotangent. See if you can derive that. Like I said, I just memorize it. So you're going to use these formulas like I would just any old derivative. I'd let u be 3x here, so du is 3dx. So I need a 1/3 out front. The integral of tangent of u, du. And I know what the integral of tangent is. It's the ln of, you can go either way here. It's the ln of secant x, so I'll write it that way. Again, I could have written the other way. That's one of the reasons you don't see these on there very often. It's the ln of the absolute value of the secant of u, which is really So you see, it's really just a formula that we're memorizing, and we're still just integrating like we normally do. I could have negative ln cosine, it's not gonna change, it's not gonna be a problem, that's how it goes. So, last thing, here's a mastery check. This is nothing to do with what we did today. This has to do with properties of integrals. So I want you to see if you can figure out which one would be the same. You can eliminate some things, and well, you can use the graph to help you, but there's a lot of things you can do. So I want you to see if you can figure out what the answer is, and take a group vote, and we'll come back after Thanksgiving and talk about this problem. Have a good break.